Hello guys, in this video I'm going to show you how to solve path with maximum problem. So find the path with the maximum sum in a given binary tree. Write a function that returns the maximum sum. A path can be defined as a sequence of nodes between any two nodes and doesn't necessarily pass through the root. Okay, so let's take a look at two examples here. Right. So the first binary tree here, the path with maximum sum will be between node 4 and node 6, right? And as you can see, the path that connect node 4 and node 6 will be, let's go from 4, go up to 2, 1, 3, and then 6. Right? So this is the case that the path with max sum will go through the root node, right? But for this example here, then the path with max sum will be defined between node 8 and node 9, and the path here will, if we start from 8, will be 8, 5, just go up to 3, and 3, and go down to 6, and then 9, right? So in contrast to the lab example, in this example, as you can see, the path with max sum is entirely within the right subtree here, right? And it does not go to the root node here, right? So let's roll back. All right. Wait a minute. All right. So can we formalize our observations? So our observation could be formalized into 3 cases, right? We have 3 cases. So the first case is the path with max sum will be on the left subtrees, on the left. Second is the path with max sum will be on the right subtree, like in this case, right? It totally entirely within the right subtree. And the final case is here, when the path with max sum go through the root node, go to root. So when it go to the root node here, it will connect one leaf node of left subtree, right, and one leaf node of the right subtree in order to form our path with max sum here. All right. So let's go into each case to see how we're gonna solve it, right? So let's say for left and right, it seems that if we consider only the left subtree or right subtree, it will become the subproblem of the original problem, right? So let's say if our original problem is uh, defined as f of root node here, right? Let's say it will be node 1. Then if we need to find the path maximum on the left hand side, it will be f of the root node of the left subtree will be 2. Here is actually a subproblem of the original problem, right? And on the right hand side here, if we need to find path maximum, then it will be f of 3, right? Where 3 is the root node of the right subtree. Alright, so seem like wanna use recursive here, right? In order to solve left and right. How are the case if we go to the root node? If I go to the root node here, if I go to the root node, the path with maxsum will connect one leaf node of the left subtree and one leaf node of the right subtree in order to form a path, right? And as you can see, node 1 here is actually unchanged, right? It fixed because we decide here that we're gonna go to root node. So can we have a formula for the case go to the root node here? Then the sum of the path will be, let's say, I'm gonna use this. It will be root r, mean the value of the root node, which is 1 here, plus what? Uh, uh, in order to generate a, in order to find the path with maximum sum, we need to maximize the path on the left and maximize the path on the right, because the root values is unchanged, right? So probably in this case, the path with maximum on the left will be the path from root to leaf of the left subtree with maxsum, right? And same on the right, the path from root to leaf on the right subtree with maxsum. Like for example here, actually in this case we can have two parts, right? We can find two parts in this case. Let's, which is here is one part, right? Here is another part. So we want the part that generate maximum sum, right? So in this case, 3 and 6 will win over 3 and 5, right? So the goal here is to find the part from root to leaf that generate maximum sum. Part root to leaf. Max instead. Max pass to leaf left, right? And max path to leaf right, right. So if we can find these three values, left, right, and the k go to root, then we could find the maximum between these three values, right? In order to find the answer for the original questions, which is uh, part with maximum sum, right? So let's say, so let's try to solve the problem here. Let's try to solve it manually to really understand how to solve it before jumping into code. Right, so we'll start. Wanna start from node 1 here, right? But node 1, our questions will be, what is the path with maximum sum of the tree with root node is node 1 here. So it's easy, the original questions, right? So in order to find the answer, I'm going to divide into 3 cases, right? The first case is, what is the part with max sum of the left subtree? Wait a minute. What is the part max sum of the left subtree? And what is the part with max sum of the right subtree? And the final case is, what is the part with max sum if the part go through the root node, right? Then if we can calculate these 3 values, we're gonna get the maximum here, right? So, but before, but first we need to solve the subproblem here first. Solve the subproblem here, and let's say, so here, so because we have delegated the questions down to the lab subtree, right? So we're gonna go through node 2 here. Okay, so our questions at node 2 would be what is the part with max sum for the binary tree, for this binary tree with root node e node 2 here. Okay, so again our questions is, again we divide the three cases. We divide three cases. The first case is the part with max sum will be on the left subtree. The part with max sum will be on the right subtree, the second case. And finally, the part with max sum will go through the root node, which is node 2 here. So we can easily see that the part with max sum of the left subtree here will be not 1, right? Will be 1 because we have only one node. Let's say the part with max sum of the left subtree will be 1. So I return back 1 to node 2 here. So the part with max sum of the right subtree will be 1 node. We had only one node, which is 3. So the maximum sum here will be 3, right? So the questions that we asked at node 2 here, so we got two answers. One is 1, first is 1, second is 3, and the last case is a case that the part will go through the root node, which is node 2. So in this case, it will be, because the part go through the root node here, so it will connect one leaf node in the left subtree and one leaf node in the right subtree. So finally we'll have 1 plus 2 plus 3, it will be 6, right? So the three cases that we have here, first one will be 1, second will be 3, and the last will be 6. And obviously 6 will win over the other two cases, right? So the answer that we return from node 2 here is, the answer that we return from node 2 here is 6. 6 is a sum, the maximum sum that we can get from the left subtree here, right? Okay, so we're done with the left hand side with the left subtree. Now we go to the right subtree to solve the second half, right? So at 3, we again asking questions, what is the part with maximum sum of this binary tree with root is root node 3, So again, three cases. Uh, Three cases. So the path remark sum first case will be on the left subtree. The path remark sum will be on the right subtree will be the second case. And final will be the path remark sum will go to the root node. So again, we delegate the problem down to left subtree here. So we go to node 5. So at node 5, we need to find the path remark sum of this binary tree, right? So 5, 7, 8. So again, we delegate problem down. So we have first case is on the left subtree. Path remark sum will be 7. Path remark sum will be on the right subtree, which is 8. And path remark sum will go to the root node, which is 5. So for this guy, I got the answer right away, which is 7 is the path remark sum. In this side, it will be 8 the path remark sum. And the last guy go to root node, which is 5. So it connect one node from left and one node from right. So here we have three cases, 7, 8, and 7 plus 5 and plus 8. So it would be 20. So 20 will win over these three cases. So the answer we return from 5 will be 20. Right. So we're done. So for the binary tree with node 3 as a root, we have successfully solved the left subtree. So the right subtree, sorry, the right subtree will go down to 6 here. So here we don't have a left node, but so how is different in this case? So again, we have to, to find the maximum sum of this binary tree. The first case is maximum will be on the left side. The path with maximum will be on the left side, but we don't have left side. So in this case, we probably only have two cases. Right? So the path with maximum will be on the right, so it will be 9. And the path with maximum will go through the root node, which is 6 in this case. So because it so the path with maximum that go through the root node will be 6 plus 9 is 15. So 15 will win over 9. So we return 15. We return 15 from 6 for node 3. So at node 3 we have saw left and right. Right. We have found the path with maximum on the left and path with maximum on the right. So it 20 and 12, 20 and 15, right? So the last case is the path with maximum that go through the root node, right? Which is node 3 here. So it will connect one node from left subtree and one node on the right subtree. Leap node to be more exact. So you may recognize that we need to not, except for maximum sum of the left subtree and maximum sum of the right subtree, we also need to return the path root to leave here for path root to leave of the left and path root to leave max path root to leave on the right, so that we can calculate for the case path root maximum will go to root node, right? So consider this binary tree with root as node 3. Then okay, let's change the color. So what do you think will be the max root to leave on the left here? It will be this, and for the on the right side here it will be this. We only have one, guys, right? So here we have two, guys, find 7 and find 8. So obviously find 8 will win over find 7. So okay, at node 3, right to node 3, we have at node 3 we have found the result of left, which is 20, of right, which is 15, and the last guy is a pattern sum that go to root. So because root is unchanged, we take the max root to leave on the left, max root to leave on the right. So here we have 14, but plus 3 here is 17, plus here is 15. So 17 plus 15 is 32, right? So obviously 32 will win over, which in this guy will be the last guy. Path root maximum go through the root node, right? Okay, so we'll return back to here, 32. Okay, so we're nearly done now. So at root, the left returns 6, the right returns 32. And finally, we need to find path with maximum that go to the root node. So root is unchanged. What is the path with maximum on the left? Sorry, what is the path from root to leaf that generate maximum sum? We have two choice, 1 and 2 and 2 and 3. So obviously this will win over. And on the right hand side we have 3 cases, 3, 5, 7, 3, 5, 8, and 3, 6, 9. So obviously 3, 6, 9 will win over. So 3, 6, 9 win over. So generally we have 3, but 2 is 5, plus 1 is 6, and 6 plus 3 is 9, 9 plus 6 is 15, 15 plus 9 is 24. So right, we have 24 here. So among the three values, 32 is the largest. So the final answer will be 33, which is the part with sum, and our part with sum will be on the right, and it is the thing that we have found here, 33, which is go to root 3 here, right? So finally we have 8, 5, 3, 6, and 9. Alright, so I think that's enough for explanations. Let's get into coding. Okay, so our function takes in a root, right? Root node, and is we need it to return the maximum sum, right? Maximum sum. But as we go to the tree here, at each function call, we need two pieces of information, right? So it must return, for one function, it must return Pareto max sum and also max root to leaf, max path root to leaf, right? Max root to leaf. Okay, so I cannot change the signatures of these functions. So one workaround here is to define a inner functions. Let's call DFS because we're using depth first search here. So it will take in the root of the current binary trees that we are considering. So this must return two pieces of information, max sum, which is something, will be something, and max sum here, and the second thing is max root to leaf, will be something we need to calculate. And finally I will return DFS, pass in the root here, the root out from the outer function here, right? Pass in to the root. This will return this object, and I only care about the max sum, right? So as we discussed, we need to recursively call functions here. So DFS pass in the left, right? Wanna solve the subproblem on the left, then solve the subproblem on the right, and this will return because DFS return these two values, so here it also needs to return max sum first and root, max root to leaf, right? Same for the second recursive call. So it returns max sum and max root. to leaf. So here we have variable with same name, so we need to aliasing. I need to make alias name here. So let's say maxsum on the, because here we're solving program on the lab. So let's say it maxsum lab. And here max root to leap, I will change to max root to leap, right? Maxsum right, and here will be max root to leap right. Okay, what is wrong here? Oh, sorry, here should be left. Okay, so we have this one too. We can calculate it now. So let's calculate this one first. Max root to leap here will be what? What do you think it will be? Let's come back here. Max root to leap, for example, at the let's say the original binary max root to leap, what it will be? So here we know max root to leap on the left, we know max root to leap on the right. So the max root to leap up the entire tree will be the value on the root node plus whatever max root to leap that generate larger sum between left and right. So here max root to leap on the right will be here, which is 9. Here we only one case, which is 6. So obviously 9 will win over 6. So here will be the max root to leap up the entire tree will be 1 plus 9, which is 10. Okay, come back. So here it will be root dot found plus whatever that is largest between max root to leap left and max root to leap right. Okay, here is for the max sum, as we discussed on about 3 cases. Max sum of the current tree could be the path that generates max sum of the current tree could be entirely on the left. So, or entirely on the right, or it could go through the root node, right? So in that case, I will need to take the maximum between these 3 values. So first value will be maxsum left. The second value is maxsum right. And third value will be the case, the path that go to the root node, right? So the root values is unchanged. So I will include it in root dot val. This is unchanged. So what else do we need here? We need max root to leap left and max root to leap right, in order to form a path go to the root node that generate maximum sum of the current tree here. Max root to leap left and max root delete right. Okay, final thing is a base case because we are calling it recursively, so we need a base case here. So what is the base case here? So let's say if I think the base case will be is when it reaches the root node, right? I can go further here. So if it's a root node, which is when we don't have left and right, we don't have left and right, which means we are at root now, at leaf now. So in that case, I need to return these two values, right? We need to conform to the signatures, function signatures, macro to leaf, macro to leaf. At the leaf node will be the leaf node value. So it will be root.var and max sum, part with max sum will actually the root node itself. So root.var again. So it could be that at one point I'm gonna, like for example here, we are 2, we go to 4, then we go to the right here, but the right is no. So in that case, we need to defend against the sky here. So if root is no, if root is no, we must return something. Right? Again, we need to return these two values. Mark path, mark root to leap. What would be here? I don't know. Mark sum. Will it be 0? Mark sum is 0. We don't have anything, so it will be 0. Or mark root to leave. So we don't have anything. So it will be no. Can we return 0 here? So let's run a test first. Okay. Okay. We have 2 passing tests and 1 failing test. Let's see. We fail at the third case here, right? It went not 1, -1 and 3. Right? So -3 is left of -1, and we don't have the right. Right? So in this case, it's expected that return -1, but receive 0. Right? So let's see why it is the case. So let's draw it down. Erase. We have let's say -1 and -3. Okay. So here we have no on the right. Okay, so let's walk through our, so -3 is will return two value, right? 2 -1 is return back here, 1, which is -3 and -3. Because we have only one node, is we are lead node etc guys, right? So it will actually the leaf node, the value of leaf node itself, whether it is max sum or max root to leaf, right? So on the no side, I'm gonna return 0 and 0 max sum and max pass sum, right? So at -1 we now compare three values, right? So let's say -3 is a max sum on the left, 0 is a max sum on the right, and part with max sum go to the root will be, in this case, -1 plus max root to leaf on the left, -3, max root to leaf on the right, and 0. So we end up with, here is -4. So among these three values, then probably we'll have to take the 0 instead, right? Which is something we don't expect, right? We want, in this case, gonna take -1 as a max sum, right? Our part we has only one node in this case. So instead of adding the value of the root here and right here, where we don't really need, right? So probably, as you can see, the problem is here, right? The problem is here, and probably also here as well. So if we reach the null, and we return 0 for the max sum, then it's gonna beat the negative values. For example, here -1, it's gonna beat -1, right? So probably if it reaches null, I don't want to return 0, but it should be more appropriate for us to return a very small value, I guess, infinity, -infinity, and -infinity. And also the problem here is that when we have so because here is infinity, so we will update 0 here to infinity. So when we have Here we're calculating the case that it go to root node minus 1. But if the path max root leaf on the left uh, is negative and max root leaf on the right also negative, we probably don't want to add up. Right? We don't want to add up in this case, so probably we need to do add some logics for these. So okay, come back to our problem. Two things to be fixed here. So the first thing is when we reach the root node here, when we don't have the root, which is the root in node, I want to return a very small number, which is infinity, minus infinity, right? And also here, down here, we probably need to do some kind of normalize here when max root to leaf on the left is less than 0. Or we can do something like max root to leaf on the left will be mat dot maximum between 0 and the current values, right? So what it means is, so here we need to change into let so that we can modify it here. So essentially this line means if the current max root leaf on the left is negative, is less than 0, then 0 will win over, right? We take the max between these, so it never gonna, the final value here will never gonna less than 0, right? It is at least it is at least has value of 0. Okay, same here. If we max root to leaf right, okay, this should fix our issues. Okay, it works now. So it's been a very long video already, so if you're watching now, thank you. So see you in the next video.